primarily infrastructure systems, what we're going to cover. We've covered everything in between. Gosh, you name it. We've gone from the outside of the facility, the grounds. We talked about landscaping. We've gone into the facility. We looked at specific items such as HVAC systems, plumbing systems, electrical distribution systems. Now what we're going to do is start looking at the infrastructure. The infrastructure, do you see that infrastructure? Like the piping in the walls and the conduit? Really, typically, they're going to be concealed, okay? So the systems that comprise the utility services for facilities are commonly referred to as utility infrastructures. So basically, this is the heart and soul of the building. So power, HVAC, process piping, in some cases specialties such as connectivity, all that makes the building a living, breathing asset is considered infrastructure, okay? So typically, infrastructure is going to be invisible to the building occupants. So in some cases, though, if you got an open ceiling, well, you don't have a drop ceiling, you get to just stare up and look at all the ductwork, right? You get to see all the conduit. Okay, that's kind of cool, right? But that's the infrastructure. With this drop ceiling, if you were to take the drop ceiling out, you'd see the ductwork. You'd probably see some VAV boxes, conduit, piping. You might see some control wiring, probably some EVAC. Okay. But typically, it's going to be invisible. You won't necessarily see it. Okay, it's going to be concealed. Utility chases, you're going to see it in vaults, such as electrical vaults or mechanical rooms. Okay, this is where the infrastructure and the large equipment is going to be housed. Okay, and rightfully so. I've always thought of building a glass wall in my chiller plant, so customers can actually look in there and see what type of equipment is in there. Okay. But I always wondered how interested they would really be in seeing, you know, old equipment running and the lights blinking and everything. I think it looked kind of cool. Okay. The primary purpose is to provide reliable and affordable service to the building occupants. Okay, regardless if it's an owned facility, if it's a leased facility. Okay, the owners in regards to the building. Services are often complex and difficult to inspect. Okay, their physical condition. So in some cases, after you build it, and this gets back to the accessibility, maintainability. After you install that particular fan coil unit above the drop ceiling and you seal it up and you walk away from it, now the condition of that particular, remember we talked about the equipment register and the equipment inventory? So getting up to this piece of equipment that's up above the drop ceiling and between piping, well, you have to remove sections of the ceiling grid to get up into it. To assess the condition is going to be extremely difficult. So this gets back to that maintainability. So as you install equipment, it's just as you know, a rule of thumb, always identify, can they actually access and get to that particular piece of equipment for that particular reason? Can we provide reliable performance out of a piece of equipment we can't even get to in the first place? And we saw some of these examples with the first central plant tour. Systems are often complex and difficult, but must be managed in order to function properly. So this gets back to your maintenance plan. So if I can't manage it and I can't inspect it, it's going to be difficult to make sure that that piece of equipment or that system is going to be reliable. Another case in point is valves. Okay, once you install a valve and you put in the hallway and say it's a hard lid, now to access that particular valve that's up above the hard, fire, if you will, envelope hallway, is going to be extremely difficult unless you have a chase or a catwalk. And in some cases, you will have some sort of utility chase to get up into these particular units. But say, for instance, that valve starts leaking, and you see a water stain in your drywall. So obviously, there's a problem. There's a water leak somewhere, or a condensate pan that you can't get to. So now, what are you going to do? Put in an access? Absolutely. You put in a scuttle hole, right, to get up into that particular valve. But the question comes back, is during new construction identifying these opportunities at that time? So again, I go back to the two central plants. The newer one, the combined heat facility that we toured, a lot of these provisions were already baked into the actual design. So there was some forethought in regards to that. A lot easier to maintain, a lot easier to inspect. If you look at the equipment and where it was located and how it was positioned between the two central plants, it's very obvious between the two that you can very easily do a walk around that particular piece of equipment. See if you got any leaking oils or seals that are going bad, or even possibly some material discoloration, such as in some of your disconnects and so on, and breakers. Okay. Again, the goal is to prevent accelerated deterioration or limit its life. Safety, reliability, and efficiency are primary objectives of the resource allocation. So our job in facilities management is to extend the life of the asset, regardless if it's a roof, if it's a wall, if it's an air conditioning unit. So what we do every day when we come to work is to make sure that the equipment is being maintained on a regular basis. Because again, getting back for capital, I want to minimize the amount of capital outlay that I'm going to have in regards to my organization, to the company. Okay? So they must be managed with similar due diligence as to any financial investment. So if I'm going to invest on capital or a piece of equipment, part of that due diligence is going to have to be maintenance. Because again, once I install it and once I start it, set it in operation and in use, okay, my goal and objective is to optimize that particular service life. It's almost like anything else. Has anybody ever bought a brand new TV? You bring a brand new TV home, and what's the first thing you do? You plug it in, right? And then did you notice every week or every day you used to dust it? You know, you get that special spray to wipe off the screen and everything. Remember that? And then how long does that last for? Maybe a month? Say 2 months. And then after that, you know, it looks fine, right? Parents aren't coming over until next month, so I'll clean it next month, right? But after a while with that brand new TV, you know, you left it on, the dog knocked it over a couple times, and you know, so on and so forth. But what you want to do, though, I mean, it costs, what, $400 or $500 now, a nice size TV? So you want to maximize the life of that TV, right? So this is the same type of analogy you would apply to your building infrastructure. I want to optimize. Imagine if that TV was in the attic, and you had to go up in the attic to watch TV. Now that wouldn't go over very well, okay? But in some cases, some pieces of equipment are located in some very difficult locations, still have to be maintained. So in regards to your performance and your time for that particular PM, you're going to include that. You're going to bake that in, okay? Increase in installation and annual operating costs coupled with aging infrastructure for the older buildings. Systems and premature depreciation pose unique challenges to FMs, okay? As I mentioned before, and in fact we saw it in the older facility, the older central plant, I have pieces of equipment that have basically been installed and the building was built around them. So for me to ever replace that particular air handler or transformer or switch gear, I would literally have to take the corridor wall apart to get access into that particular piece of equipment, okay? Now in hindsight, if I would have had double doors installed or maybe a roll-up dock door installed, for me it'd be a no-brainer. For me it'd be, well, it's just plug and play. I take this one off the equipment pad, set it up with the rigging company, and go ahead and remove it and put the new one in. But in the case where I have to move equipment, do you remember what the folks in the older central plant had to do with their motors? They had literally had to take them apart, set them aside, put them in a cart or a little dolly, wheel them to the next hoist, and then lift them over another chiller, set it back on a dolly. So they actually had to do the leapfrog effect. Okay? If we were to do this all over again for them, we probably would have put a trolley hoist of some sort, where you lift one motor, basically take it over the top of the chillers and set the new one on. Okay? Decrease accelerated deterioration through effective and efficient maintenance practices. So again, extending equipment life, okay, life of the asset. Okay? So what are some of the useful life elements? Okay? So the equipment and systems usage is estimated useful life versus estimated remaining useful life. Remaining useful life is the actual condition of the piece of equipment. One, the pan's rusted through. Two, are the disconnects, where you've had a lot of arcing. Are they giving reliability problems? So the estimated remaining useful life is what's going to come down in your capital plan. So say, for instance, we went into that first central plant and we were going to conduct a estimated remaining useful life. Okay, we looked at the pieces of equipment. What do you think the prognosis would be? What do you give that piece of equipment? A year, 2 years, 3 years? Say it was a newer pump. You know, we'll set the pump, says, well, you know, you can at least get 10 years providing it's maintained on a regular basis. But some of the other pieces of equipment, the ones that were leaking grease, the ones that had oil stains underneath them, I mean, that's a fact. Part of the write-up, they mentioned that they heard a noise where a bearing was going out. But in those particular ones, the estimated remaining useful life may be hours on that particular ones. So first thing we would probably do is come in with a predictive maintenance program, either conduct an ultrasonic or an infrared or vibration testing. Now your picture starts to kind of unwind here, because now you identify the pieces of equipment that has some significant physical challenges. So with that, now I can calculate the remaining estimated useful life of that particular piece of equipment. So can I prioritize now? Sure, right? So if I have pumps that are going to last 5 years versus estimated 2 years versus estimated 6 months, now I can start to prioritize what I have to replace first, second, and third. Okay? Equipment performance expected versus actual expected life. Predictive and preventative maintenance. Okay, water treatment comes up again. Why is water treatment so important in a maintenance plan? You know, we've been covering water treatment for the entire semester, right? Okay. And water, is it a corrosive? Okay, it's probably just as bad as any acid that you would have or any other type of contaminant. But when it comes to the water systems within your infrastructure, this is more than just air handlers. This is water piping or sprinkler piping. Okay? Electrolysis, where you start to corrode the fittings from within your piping. Now, there's one thing if you can actually walk in a hallway and see that pipe starting to decay and corrode. It says, you know, I need to replace that pipe. What about pipe you haven't seen for 30 years? So when you conduct renovations and you have a chance to remove the drop ceiling and you start looking at the infrastructure, you know, you have a whole team that goes through and assesses the infrastructure. So they'll look at sprinkler piping and they'll look for pinholes. They'll look for signs where it was starting to leak around fittings, Vitulic fittings, pumps, valves, traps, condensers. So you'll have a team that will come in and assess that while the construction and renovation is going on. Now, once you lose your insulation quality, okay, now that affects your overall. Remember my pipe that I mentioned that split? Well, part of that reason, problem with that particular pipe on my chill water, is my insulation degraded. Over time, the insulation properties, with it being wet, and it was jacketed, but it was wet over time, that it was actually added to the freezing of that particular pipe. So insulation, so absolutely, they will peel that back to determine what is the source. Is it a fitting? They'll note it, and they'll usually work it out with the general contractor to determine, says, you know, can I add another 2 weeks to your schedule so I can go in there and conduct infrastructure, either repairs, upgrades, or full replacements. So that's the best way to do it. So, yeah. And in these cases here, what you're doing now is partnering with your GC, with your general contractor. So you got your facilities right side of the house, and you have your new construction. But between the two, when you turn that particular building over, or that room or auditorium, so not only has the infrastructure been upgraded, but the building systems as well. So now you get a turnkey. So it's a good opportunity to improve the reliability. Operator proficiency is another one. Training and experience. What to look for. Okay, as you walk through your equipment and you walk through the areas, having that eye, if you will, that keen eye, to identify potential problems. Okay. When I walked through the older central plant, I noticed a lot of J boxes that didn't have the covers on them. They had a lot of the wires sticking out. Now, if nobody fiddles with the wires, right, it's probably okay. But in some cases, though, over time, okay, if that continues, it may cause problems from within that central plant. Wire nuts that have fallen off, and all you got really is your leads that are twisted together. You know, again, that's an accident waiting to happen. Other cases is you may get some calcium or some mineral deposits on valves, and you're starting to see that valve is starting to degrade. So it's like, well, I'm not checking valves, I'm checking air handler coils. But part of your training should be, you know, I need to report that valve. PIV valves, okay? PIV valves for your fire protection loops, okay? Those valves are buried typically 10 feet into the ground, okay? And you do have a procedure, okay? Turn them clockwise and counterclockwise and break that band, okay? And then you spin them open and you spin them completely closed. And that's a regular PM. It happens every 3 months. What happens with that is there's so much condensate down in the soil, it will tend to usually bind your gearing mechanisms on the bottom of that PIV valve. Gate valves and butterfly valves, okay? Automatic valves would be another one. Regular exercises is just like you have your disconnects and in some cases your motor control centers. Breakers, regular exercise, and valves are going to have the same procedure. So in these cases here, do you take it all the way out to the seat, or do you turn it in a quarter turn? Okay. Again, packing, looking at the packing, looking at the seals. Okay. You know, it's just, it's amazing as to how much maintenance goes into any building that they have a proper procedure. In some cases, they may never do any maintenance and basically let the building run to fail. Okay. So part of the training would be is to always look for observations, such as condensate pan. It's not the middle of August. Right now it's the middle of January. I have no humidity, but yet when I look down at my condensate pan, it's full of water. So one indication is going to be is I may have a chilled or hot water coil that's leaking. And maybe it's more than a fitting. Maybe it's part of, could be a connection or a coupling, or it could be a valve. So again, part of the training is to look for these, okay? And of course, the future availability phase out the obsolete, okay, pieces of equipment. And this, again, we go back with some sort of priority plan. Okay, identifying the oldest pieces of equipment and assessing their condition and their remaining useful life, okay? Okay, so this is just overall boiler types. First one would be the fire tube. These are the ones that we looked. Remember the fire eye when you looked at it and you actually saw the fire flowing over the tubes? That's an indication as to the site of the flame, as to how well it's burning, how efficient, other than the emissions and the flue, but also how well that particular boiler is operating. So this one here is determined by the method of heat transfer. How well can it generate heat, okay, with the amount of flame? How fast can you bring the hot water system up to speed? Okay? So every fall, there's a phenomenon that happens at every building, every facility, every campus. And that is, you start your hot water systems up. And it typically takes about 8 hours to bring a full loop up to temperature. Okay, the second item you look at is your emissions out of your boiler. And then do you maintain that temperature? Because basically, it's your water heater at home. You only want to cycle it for as much as you need. Okay, so you don't want to keep it at that temperature on a regular basis. Okay, so this particular one here, it's surrounded by a fluid chamber, so you've got water that floods your tubes. The tubes themselves are fire heated, so you heat the insides of the tubes up, okay, and it warms the water outside of the chamber. And you have a circulation pump that continues to pump that through, and it maintains that particular temperature. Okay. Package units or field-directed units are typically factory installed, so they're really plug and play. So they'll come back typically in the back of a semi or a truck or train, and basically you'll crane them and you set them in place, you connect them, you set the controls up, and you install the piping. Okay, so they're really pre-packaged. Steam or hot water generation. Okay, majority of the boiler units in the U.S. are designed as steam generators, okay, producing steam. Okay, typically designed around steam as a process heat source. So the combined heat facility, just based on the amount of energy that they were turning out of that turbine, the byproduct is heat. So part of that heat, they were using the excess heat to run an additional generator, and then also heat for the campus. So they had one or two uses of that particular wasted energy, if you will. Other than that, it would have evaporated into the atmosphere. Okay, in this particular case here, you get another cycle, a sustainability initiative. Okay, and typically operating pressures, okay, pounds per square inch gauge, low pressures is 20 pounds or less. Medium pressure is 20 to 150. And high pressure, this is where it becomes a hazard, especially in some of, well, in the case of Coast Guard and some of the ships that have steam-generated, okay, turbines. And in some cases, the steam temperatures, you know, you've heard that they could be extremely hazardous because, one, you can't see the steam, okay, as it's escaping, but the temperature that it has, you know, will burn you severely, okay, if not injure you as well. Okay, so that's where maintenance really comes into play, where you have your predictive maintenance program to identify if there's any steam leaks and drops in pressure and drops in temperature. Okay, and then the other items, these are your 4 basic types of fuel for any type of boiler use. Is coal, natural gas, fuel, oil. You're probably familiar with all of these. Okay, coal obviously is a very inexpensive source of fuel. Okay, very dirty fuel to use. Costly in emissions, again, trying to scrub, you know, the byproducts out of that. Okay, so increasing transportation and rail transportation's inefficiencies. You know, it's funny because we have an entire infrastructure rail systems. But again, you got to remember the rail systems are what, over 100 years old? So they only go to certain destinations. So as you add additional coal mining, bringing that rail yard, if you will, to the back of into the infrastructure for the rest of the rail systems become costly, because in some cases you got to go over terrain. But that's something they're saying, that the aging rail networks and the general lack of transportation capacity is preventing this amount of coal to be generated. So you build the power generation facility next to your source, next to your coal source, okay, in those particular cases. Natural gas, typically a cleaner burning fuel. Okay, so if I was to have a choice, I'd probably go with a natural gas boiler. Okay. However, legislation, production needs, and import oil pricing affect the cost of natural gas. So in some cases, it's liquefied natural gas that comes in, and the cost. The cost per therm of natural gas is going to determine when I'm going to run the boilers, much less for power generation. And fuel oil, typically that's going to be used as standby fuel. And we remember the old central plant, their boilers, they actually had an oil tank. Okay, that was what buried. You saw the big lines came up into the boilers. Okay, but again, it's not a very efficient burning fuel, but it is an energy source in that particular one. And of course, biomass, such as wood, your wood chips. You're talking plant material, anything that burns to produce energy or heat. Okay, but what they're wrestling with now is that there's a phenomenon called sustainability. So when you get oats, the remainders of your agriculture, such as wheat, they're using that for materials, for building materials. So now, the commodity is that particular material. So now you're competing against, one is if I'm going to burn it or I'm going to use it for a countertop. So there's a phenomenon that occurred about 10 years ago. So a lot of these sources, so I don't have to mine trees, okay? I'm going to use the byproducts from agricultural activities, and I'm going to compress that, and I'm going to use that for wall materials, tabletops, countertops, and so on. But yet on the other hand, I could also use that to what? Fuel. I can use that as some sort of fuel source. So there's definitely a competition going on. That's why it's turned out to be a commodity at this point. Okay. And then just talk a little bit about different types of chillers. Basically, 3 types of chillers: centrifugal, absorption, and rotary screw compressed chillers. 3 basic main types of machinery that you're going to see in any facility, building, okay, or campus. Now, how they measure the efficiency of the chiller and how well it operates, okay, how efficient it is they use a performance efficiency, okay, or COP, is the ratio of useful thermal energy produced by the output energy required to produce the cooling energy. So the amount of BTUs that is starting to process through the chiller on how efficient that it meets that temperature is going to be your performance standard. And coincidentally, you have the same criteria for a boiler, okay? So I won't get into the specifics of the equation, but there is a measurement, okay, criteria on how efficient a boiler is going to operate.